Before starting this lesson, try the warm-up question. Evaluate this expression, 5 over 7 to the exponent 2. So pause the video and try it, and then see how you did. So you just have to remember what an exponent means. An exponent means that's how many times you're multiplying this by itself. So if we have an exponent of 2, it means 5 over 7 is multiplied by itself 2 times. So there we go. When you're multiplying fractions, it's the numerator multiplied by the numerator gets you the new numerator. The denominator multiplied by the denominator gets you the new denominator. So our answer is 25 over 49. So this lesson is from Spiral 1, Topic 1. This is Lesson 3. Write today's date, and the title is Ratios, Rates, and Proportions. So we're going to review what those are, what ratios, rates, and proportions are, and what to do with them. So first off, we'll talk about a ratio. A ratio is a comparison between quantities with the same units. So for example, you could be comparing the number of boys versus the number of girls in a classroom. It's the same units because we're just talking about number of people. You could also think of the score in a game. So if your favorite team has 3 points and the opposing team has 2 points, that's a score of 3-2. This is a comparison of points, same units. And we can represent these ratios in different ways. For example, I can write the ratio 15:5 like this, where I have a colon in between the two values. So this is a comparison of this to this. But I can also write the same ratio as a fraction. So 15:5 can be written like this, or it can be written as 15:5 like this as a fraction. Either way works when you're representing a ratio. Now, the other thing too is ratios can be represented in lowest terms, just like any fraction. So 15:5 can also be written as 3:1. So let's just say, as a hypothetical situation, there's 15 girls and 5 boys in a classroom. Well, the ratio of girls to boys is 15:5. We can write that as a fraction, 15:5, but really, in lowest terms, that's a 3:1 ratio. So that means for every 1 boy, there's 3 girls in the room. So that's kind of how we can understand ratios. We can write them like this, or we can write them as fractions and use the same rules for fractions that we're used to. Now, a rate is different than a ratio. A ratio compared quantities with the same units, but a rate is a comparison between quantities with different units. Often we are interested in the unit rate, or the amount for 1 unit. So I'll give you an example. When you're driving in a car, you're dealing with a rate, your rate of speed, which we write as kilometers per hour. That's a rate. It's a comparison between kilometers and hours. Those are different units. One is for distance, one is for time. And the unit rate, again, would be our speed is in kilometers per hour. It's for 1 hour. The unit is for 1 hour. And you can think of, in the grocery store, you go shopping, you can get the unit rate, or how many dollars per kilogram, or dollars per gram, or something like that. Or when you're buying gasoline at the gas station, the price is usually listed as cents per liter. So that's the unit rate. It's the amount of money it costs for 1 liter. So as an example, let's say it took us 5 hours to drive 400 kilometers. Well, we can set that up as a rate. It's a comparison, so we can write it the same way we did before, where we use the colon, 400 kilometers to 5 hours. That's the comparison. Or we can set this up as a fraction, 400 kilometers over 5 hours. And when you write it as a fraction, you often pronounce the fraction line, the dividing line, as per. So it's 400 kilometers per 5 hours. And if you want the unit rate, we want it per 1 hour or per hour. So we need to be able to reduce our fraction to lowest terms. That's really what we're doing. So both of these numbers end in 5 or 0, which means they're both divisible by 5. So if you divide the top and the bottom both by 5, you end up with 80 kilometers per 1 hour, or we would typically write this as 80 kilometers per hour. And that would be your speed or your unit rate. So a ratio compares two quantities with the same units. A rate compares different quantities with different units. So let's do some examples. Here's some ratios. Here I'm comparing two quantities, 32 to 18, and we want to put them in lowest terms. So if it helps, you can write it as a fraction. You don't need to for this question though, but the principle is the same. To reduce this to lowest terms, you have to find common factors that you can divide by. And if you're looking for some shortcuts, well, these are both even numbers. Every even number is divisible by 2. So you can start with that and then just keep going if you want. So if I divide both of these by 2, I end up with, well, 16 to 9. Okay, now, are there any numbers that can go into 16 and 9? Well, no, there aren't any, so this is lowest terms right now. Now this example, this is a ratio with 3 quantities being compared, and we want it in lowest terms still. It's not really that much more difficult than what we did here. It's just you have to keep track of 3 different numbers instead of just 2. But regardless, these 3 numbers are all even numbers, which means they can all be divided by 2. So if we do that, 12 divided by 2 is 6, 60 divided by 2 is 30, 84 divided by 2 is, well, if you're having trouble with that in your head, we can do some mental math. 80 divided by 2, half of 80 is 40, half of 4 is 2. So half of 84 is 42. So we can write that. And now we notice these numbers are still all even numbers, which means we can divide by 2 again. So 6 divided by 2 is 3, 30 divided by 2 is 15, and 42 divided by 2, well, half of 40 is 20, half of 2 is 1, so 21. Now here, some people are going to stop because they don't see an even number anymore, which means you can't divide by 2. But look at your smallest number. It's a 3. So the only factors of 3 are 1 and 3. So let's check 3. Can 3 go into any of these? Well, yes, because 3 times 5 is 15, and 3 times 7 is 21. So our ratio reduces to divide each of them by 3. It's 1 to 5 to 7. So that would be our ratio in lowest terms. So again, just because you're comparing more than 2 numbers doesn't mean that it's different in how you reduce it to lowest terms. You just have to make sure you're dividing by a number that goes into all 3 values, not just the 2 of them. Okay, for these ones, you want to determine the unit rate. Remember, unit rate is per one thing. So here we have 12.8 million views for 28 videos. I want you to figure out what's the rate of views per video. And here it's 215 points in 80 games. I want you to figure out the rate of points per game. So pause the video and try it, and then check back in to see how you did. So I'm writing this as a fraction. It's, 12.8 million is 12,800,000 views for 28 videos. That's how the fraction looks. And you might have reduced this to a fraction in lowest terms, which would give you this. 3,200,000 views for 7 videos. But remember, yes, this is lowest terms, but it's not the unit rate. Unit rate means we want it for 1 video. So we're going to have to divide. If you got this far, you can just do the division. 3 12.2 million divided by 7, or you could just do it right off the bat. The 12.8 million divided by 28 gives you this many views per video. Now, there's more than one digit after the decimal when you do this in your calculator. I just rounded it to the first digit, and because I rounded my answer, notice I put a dot above the equal sign. That means this is an approximately equal to this value. It's not exact. Here, this is an exact value because it's an exact fraction. I haven't rounded any numbers, but as soon as I do a calculation in my calculator and it gives me a decimal, basically if my screen is filled with decimals, I know that there's some rounding that has happened, and I'm going to put a dot above my equal sign. So this is what you would get. You could even round this to a whole number, 457,143 views per video. You could say that. But regardless, if you round your answer, you put a dot above the equal sign. That's just proper communication. Next one, 215 points in 80 games. There's the fraction. You can reduce it to lowest terms, but still, that's not the unit rate. We want it points per one game. So we can do 215 divided by 80, rounds to 2.7 approximately, or you could just round it to 3. It's approximately 3 points per game. Okay, so here's a word problem. Now, we haven't done any of these yet, but with word problems, basically this is just somebody's attempt at explaining a situation that you have to solve. You have to solve the problem explained in this situation. And I wrote this one, but if you're looking in the textbook, someone else would have written it, and it's the author's best attempt at explaining a situation. So sometimes when you're trying to explain a situation, it's not really the best. The best would be to actually experience the situation, but we're limited with, we have to do this in a classroom. So this is my best attempt at explaining the situation that Bob finds himself in. And just a note here, if you ever, in my class, feel like you don't really understand what the question is asking you to do, or the situation is unclear, you don't really know what's going on, just ask and I'll do my best to help you figure it out better, even draw a picture or something. But let's take a look at this. Bob is looking for the best deal on canned ham. At Sobeys, he can buy 8 cans for $4.99, but at No Frills, he can buy 6 cans for $3.49. Which deal should he take, and how much will he save by getting that deal? So here's a situation where the comparison is not really the same. This costs more, but you get more too. So which one is the actual better deal? So most of the times when you're faced with this situation, the unit price is what you would want to use for a fair comparison. So when I say unit price, I mean what does it cost for 1 can in each situation? So 8 cans for $4.99, what does it cost for 1 can? Here it's 6 cans for $3.49. How much does it cost for 1 can? Once we have the cost for 1 can at each store, then we can compare the price of 1 can, and then we can more easily see what the best deal is. So here's how I'm going to set up my solution. When I write a solution to a word problem, I want to make it organized so whoever's looking at my solution can understand what my thought process was really. So my thought process is, let's figure out the unit price at Sobeys, then let's figure out the unit price at No Frills, and then over here we're going to write the conclusion. Okay, so you don't want to write your first step over here, then you went over here and did some math, and then you just have some numbers circled. Like, you got to make it organized so that it's easy to follow. That's proper communication. Okay, so at Sobeys, it's $4.99 for 8 cans. Let's just find the unit price. So $4.99 divided by 8. When I round my answer, I get approximately 62 cents per can. Now let's do the same thing with No Frills. $3.49 divided by 6. you get approximately 58 cents per can. So now we can make a conclusion. This is the better deal, so he should take the deal from No Frills because he will save, well, what's the difference? About 4 cents per can. So anytime you do your calculations and make a conclusion for your word problem, always go back to the question and see if you actually answered everything it's asking. So it says, which deal should he take? Did we answer that? Yes. How much will he save by getting that deal? Yes, we said that too. So with a word problem, try to visualize a situation, come up with a plan, make your plan known, like what's your thought process by making it organized, and then make sure you've made a conclusion and you've answered everything that you're actually being asked to find. This question's a little bit different because here you're given the ratio of Snapchat users to Instagram users, and it tells you how many Instagram users there are, but you need to find out how many Snapchatters there are. So this one you might have to do kind of a little bit of working backwards, but I'd like you to try it on your own. So pause the video, see what you come up with, and then you can check back in to see how you did. Now, if you couldn't figure out how to solve this problem right now, that's fine. I'm going to show you in a minute how you can attack this problem in a different way, but I'm going to show you what the most common method is for grade 9 students at this point. We would set up a ratio, so the number of Snapchatters compared with the number of Instagrammers. We're told that the ratio is 4:3, so that's what I start with. But then I'm told there's 75 million Instagrammers, so on the Instagram side of the ratio, I'm going to say it's 75 million. But I don't know how many Snapchatters there are, so I just replaced that unknown number with a variable. It's the letter X. So this just represents my unknown number that goes in this spot. Now, because this ratio is fixed, for every 3 Instagrammers, there are 4 Snapchatters. Whatever I multiply this by to get a new number, we're going to do the same thing on the other side. So I figured out that if I multiplied 3 by 25 million, I would get this 75 million. So if I took the top number multiplied by 25 million to get my new number, then I would do the same thing over here. 4 times 25 million gets me my unknown value that goes in this spot. So 4 times 25 million is 100 million. So that tells me how many Snapchatters there are compared to the 75 million Instagrammers. So I made my conclusion, therefore there are 100 million Snapchatters. Now this symbol, you might not be familiar with that. The 3 dots that form a triangle, that's therefore. And the word therefore just means because of what I just showed you up above, I can say this. So because of this math, I can say there are 100 million Snapchatters. And that's how you can solve this problem. And this leads me to the idea of the proportion. So a proportion is a statement that 2 ratios are equal. So in the example I just showed you, I had the ratios 4:3 and 100 million to 75 million. Those ratios are equivalent or equal. And that's what I'm saying. A proportion is just a statement saying that those 2 ratios are equal. So whenever you have a proportion, oftentimes you're missing a value. So you need to figure out what the missing value is in the proportion. So there's kind of 2 basic methods you can use. One is look for a multiplying pattern. That's what I did in the previous example. I saw, well, if I multiply this by 25 million, then I get this. So I can do the same on the other side. That's what I mean by a multiplying pattern. The other method that oftentimes is more useful because sometimes you can't find a multiplying pattern that's nice, with a nice whole number. So the other method is cross multiply and divide. So I'm going to show you some examples now that deal with solving proportions. So when it says determine the value of x, x is a number. The only thing is we just don't know what the value of that number is. So here I have a proportion. This ratio is equal to this ratio. I don't know what this number is though, so I have to figure it out. So I can either look for a multiplying pattern or do cross multiplication. So first off, this one, if you know your times tables well, you'll know that there's a relationship between 9 and 45. It's 9 times 5 gets you 45. So if we know that multiplying pattern, it's going to be the same thing down here. So x is just 13 times 5, which is 65. Now in the next one, here's a ratio. It's equal to this ratio, so that's a proportion. We don't know what this number is though. But same as what we did here, we can see the pattern. Well, if you know your 12 times tables, you'll know that 12 times 5 is 60. So we compare the first number in the list with the first number in the list. It's times 5. So to go from the last number to the last number, it's going to be the same, times 5. So in this case, x is 17 times 5, which is 85. Now these are fairly straightforward because if you know your times tables, you can find the pattern fairly easily. But what about this? 5 to 8 is equal to x to 20. Well, if you know your times tables, you'll know that there's no whole number times 8 that gets you 20. So this one's not as straightforward. This is where I'm going to show you cross multiplication. So what we do is, the cross multiplication part comes from we multiply the numbers that are on diagonals. So 5 times 20 is equal to 8 times x. Like this. So that cross multiply what's a diagonal to make a cross or an x. So 5 times 20 equals 8 times x. So let's just carry on. So 5 times 20 is 100. So 100 equals 8 times x. So 8 times something gets an answer of 100. Well, to figure out the something, we got to kind of work backwards. Well, something times 8 gets us 100. If you work backwards, 100 divided by 8 gets us the something. So in this case, x is 12.5. Now, just a note about communication here. Notice I did not write an equal sign here. Each line should only have one equal sign. That's proper notation. So here I have 5 over 8 equals x over 20. Next line, 5 times 20 equals 8x. I ran out of space to keep going down, so that's why I put an arrow here. This tells the person reading the solution, well, I started here, we always work down, I ran out of space, I went up here. Now this is where the continuation happens, and I keep working down from there. Each line only has one equal sign, so that you only have one thought per line, in a sense. Okay, so cross multiplication, you multiply the diagonals, but then we ended up dividing by this 8 here. So a shortcut would be multiply the two diagonal numbers that you know and divide by the number left over, and that will get you your missing value. And that's kind of the way we're going to attack the next set of examples. So here we have 23 divided by 5 equals x over 12. I don't think that you can find a multiplying pattern with a nice whole number, so I'm going to do cross multiply. So multiply the diagonals, divide by the number left over. So x is equal to 23 times 12 divided by 5. You can just go ahead and do the math. You end up with 55.2. In the next one, we have 8.3 over 157 equals 67 over x. We want to know what x is, so we're going to multiply the diagonals, divide by the number left over. So x is 67 times 157 divided by 8.3. And when you punch that into your calculator, you end up with 1,267.349398. Your calculator is filled with numbers, so you know that is not an exact value. So we're going to round this. So I've chosen just to round it to the second digit after the decimal, just to show you something with rounding. Just a lot of people feel tempted to just, if they want to round to the second decimal value, they just cut off the rest and just ignore it. So they would write this as 0.34. But remember your rules of rounding. Look at the digit beside. If it's 5 or greater, you round that up. So this is actually closer to 0.35 than it is to 0.34. So I would round it to 0.35 at the end. And remember, anytime you have any rounding or you have an inexact, not an exact value as your answer, you put a dot above the equal sign. So hopefully you know the difference between a ratio and a rate, and you can solve proportions. If you have any questions or not understanding, just let me know and I'll do my best to help. Otherwise, move on to the practice questions.